So graphs, if you are taking with time and concentration. On y-axis I have taken concentration, on x-axis time I have taken. When time increases, the rate, for example, A gives rise to B, time increasing, concentration of A is going to be increases or decreases? Decreases. So initially reactant concentration, you can assume this one is from here, it's going to be decrease. So this reaction is for irreversible. This graph is for irreversible. This is rate of forward reaction. Rate of forward reaction is going to be decreased with respect to time. Why? Because reactants are going to be consumed at certain point. The A will be 0. 0 will means the forward reaction is stopped. So at concentration of A will be at finally 0. The rate of forward reaction is inversely proportional to time. Backward reaction, okay, it is irreversible. Take the reversible. Now time, concentration, products concentration is going to be increase. Reactant concentrations decrease. At certain point both are equilibrium. This point we can call as equilibrium state. This one is rate of forward reaction, products increasing, rate of backward reaction. This point is Rf is equal to Rp. Now this is equilibrium state. What is a dynamic equilibrium state means? Dynamic equilibrium. Equilibrium means the rate of forward reaction will be equal to rate of backward reaction. So at equilibrium state, all measurable properties, concentration, volume, density, moles, all will be constant. But here if you are taking dynamic equilibrium, all concentrations of reactant may be same or may not be same. For example, for irreversible, I am taking time. This one is concentration. Sum of the reactant to product. Some of the reactant only reacted, some of the product is formed. Fully it is not formed. Means reactant concentration will be slowly decreased to some point. The product will be forms only how much reactant is consumed, that much product will be formed. So here see concentration of reactant which is not equal to products concentration. See reactant concentration will be this point, this line. The products concentration will be this line. This is products concentration, this one is reactant concentration. Both concentrations will be not same. But here concentration of A and B same. See this line. This concentration will be same point. But here it's different. With the difference concentration also, they will show same at the 1 minute. At a time with respect to time, the concentration will be not equal to products and reactant, but it will be constant with respect to time. See here, the reactant concentration will be constant. The products concentration also constant. With the different of concentration of products and reactants, it will be attained to equilibrium. What is equilibrium? Concentration will be constant, volume is equal to constant, density is equal to constant, molarity is equal to constant, moles is equal to constant. All measurable properties will be constant. Here you can see the concentration of reactant is There is no changes. See, this is the concentration line. For example, this is 0.5. See, it is 5 only, right? There is no change in reactant concentration. This is 3, you can assume. See, concentration will be 3 only. So if it's at constant concentration, there is no change in the concentration of reactants and products. This equilibrium is going to be called as dynamic equilibrium. With the same concentration of products and reactants, we can call as normal equilibrium. This one is dynamic equilibrium. One more, time I am taking and concentration. More reactant is consumed, more product will be formed. Here 20% reaction is going to be taking place, means how much percentage of reactant is consumed? 20%. How much product is formed? 20%. So here I am taking 70% of reaction is completed, means reactant is 70% consumes, 70% reactant is formed. So reaction is completed by 70%. Now products concentration I am taking this one, reactant concentration high to low. It is not coming to 0. See, it is 30% remaining is there. This is the 0 line. It is not coming to 0, means reaction is not never be completed. Reversible reaction will be not completed. Why? Because we are going to be taking in closed vessel, the products will be formed and again it's going to be forms reactants. Any one of the concentration is reached to x-axis, then the reaction is going to be complete 100%. That is irreversible. Now the reaction is not going to be complete. Now reactant concentration will be higher or not or lesser? According to this graph, reactant, this one is reactant concentration decreasing, products concentration in increasing. Which one is more? Products concentration. After formation of reaction, the concentration of product and reactant will be constant. This state we can call as dynamic equilibrium. Here we can take any one of the constant point. If it is started constant point here, means this is the dynamic equilibrium. We taken that too. Taken this. Law of mass action is nothing but, it was introduced by Goldberg and Vaggi. So what is the law of mass action is nothing but rate of forward reaction is proportional to the active mass of products, active mass of reactants. Rate of backward reaction is proportional to the active mass of products. So what is the meaning of active mass? Active mass is nothing but the mass which is active. The mass which is active, or which mass is going to be participate first in the reaction. That one is going to be called as active mass, which is denoted by concentration. This is called as active mass. Formula is same for active mass and concentration. Formula is number of moles by volume. This is nothing but active mass. So what we can write is, for example, A gives rise to B I have taken. Rate of forward reaction means what we can write? RF directly proportional to reactant. What is the reactant? A. Active mass of A. Active mass of A is nothing but concentration of A. RB is directly proportional to concentration of B. If I am taking RF, it's equal to KF into A concentration. KF is the equilibrium constant of equilibrium constant of forward reaction. If you are taking RB is equal to KB into B. This is equilibrium constant of backward reaction. At equilibrium, both are equal. So that is called as law of mass action. Law of mass action is nothing but rate of forward reaction is directly proportional to the active mass of reactants, and backward reaction is directly proportional to the active mass of. So that is called as law of mass action. Write the definition. It is proposed by Goldberg and Waggy. According to this law, the rate of forward reaction is proportional to the products of or product of active mass of products, reactants, and the rate of backward reaction. Reaction is proportional to product of active mass of reactants, products. So RF is proportional to, I am taking a reaction, A plus B gives rise to C plus D. Taking a equilibrium reaction, rate of forward reaction is directly proportional to product of active mass of products. So product of means product of C and D. Active mass of C is bracket of C. Active mass of D means D. So this is rate of forward reaction, which is equal to, I am taking a proportionality constant of RF is equal to Kf into concentration of see we need to take reactants, A concentration, B concentration, which is equal to RF is equal to Kf into A concentration into B concentration. Kf is nothing but equilibrium constant of forward reaction. Right, backward, RB directly proportional to concentration of product or active mass of products. Concentration of C into concentration of D. So RB directly is equal to Kb into concentration of C into concentration of D. Kb is equal to equilibrium constant of backward reaction. So what we can take at equilibrium? At equilibrium, what we can say? RF is equal to RB. Rate of forward reaction is equal to rate of backward. Equal that to, what is RF? Kf into A concentration, B concentration, which is equal to Kb into C concentration into D concentration. Kf by Kb. Kf by Kb is equal to C concentration by D concentration, C concentration into D concentration by A concentration into B concentration. What we can take? This one is ratio of forward equilibrium constant of forward by ratio backward reaction, which is equal to equilibrium constant. Equilibrium constant, which is equal to, what is the formula? From this formula we can say the definition. Equilibrium constant is nothing but product of concentrations of C plus D. C and D are products only, right? So the product of concentration of products to the product of concentration of reactants, and each concentration term of reactant or product which is equal to power, which is raised to power, which is equal to, what is the coefficient will be there here. Here coefficient is 1. Here coefficient is 1. 1, 1. What is the coefficient will be present in the reaction, in balanced reaction? That coefficient will be comes on the power 2 concentration of A or B or C or D. What is the coefficient is there for A? That is the that is the power of A in equilibrium constant. Why it is also, I will tell you. Completed? I am taking one example. 2A plus 3B gives rise to C plus 2D. Rate of forward reaction, what you can write? R, okay. Here concentration of A is there and concentration of A is there. Two concentrations of means two reactants we are taking, right? So concentration of one is 1 of active mass of A and second active mass of A. Two active masses will be there here. Here 3 into active masses of B. Here 1 active mass of C. Here 2 active masses. D into T. Now K equilibrium means what we can write formula? Product of concentrations of products to the product of concentration of reactants. So what are the concentrations of products here? C concentration into D concentration into B concentration by here A concentration into A concentration into B concentration into B concentration into B concentration. Then we can take these two are squares. C concentration into D concentration by A concentration square by into B concentration of Q. Now what is the coefficient will be there here 2? What is the A concentration of A power? 2. Here concentration B coefficient is 3. What is the concentration power is 3. So what is the equilibrium constant definition? It is the ratio of product of concentrations of products to the product of concentration of reactants, and each concentration term is raised to power the number is equal to coefficient of a substance in a balanced chemical reaction. In a balanced chemical reaction, that is called as equilibrium constant. Equilibrium constant is nothing but product of concentration of products by product of concentration of reactants. It is the ratio, and each concentration term is raised to power the number which is equal to coefficient of reactants or products in a balanced chemical reaction. That is called as chemical equilibrium. Take it. N2 plus 3H2 is forms 2 moles of ammonia. Write equilibrium constant for this reaction. What is the equilibrium constant? Product of concentration of products. Here only one product is there. It is concentration of NH3, coefficient is 2. So it will be square by, here two reactants will be there, N2 and H2 power cube. Here N2 power is 1. So that is equilibrium constant of ammonia reaction. Now active mass. What is the meaning of active mass? The mass which is react first in the reaction is called as active mass. Active mass we can derive in two types. One is pressure, one is in terms of concentration. For example, in terms of concentration, solute dissolve in solvent or solution. If I taken this one, I need to find out the concentration. If it is solid, we can find the concentration. If it is pressure, if it is gas, we need to find out the pressure. So two types will be there. Now if you are taking solute concentration, how can you find? Number of moles by volume. So number of moles formula, weight by molecular weight into volume. So weight by you can write 1 by molecular weight into weight by volume. Weight by volume means mass by volume formula. Density by molecular weight. So we can find the concentration of, in this formula is 1 and this is 1. We can find in the case of this one, or we can find in this case. Active mass square brackets is equal to number of moles by volume. We need to show that active mass with empty square brackets. Next, if it is pressure, we have the formula. What is that? For gases, PV is equal to nRT. So P is equal to N by V RT. In place of N by V, what we can write? P is equal to concentration of RT. This is one form. Find the active mass for 56 grams of N2 in 10 liters. What is the answer? How can you find? Concentration or active mass which is equal to the given weight and volume. Which formula we need to use? N by V. So number of moles, how can you find? Weight by gram molecular weight into 1 by volume. Weight they given 56. Gram molecular weight of N2 28 into 1 by 10, which is equal to, this is 1s are 2s are 2 by 10 is equal to 1 by 5, which is equal to 0.2 molar. Take it. So the density of N2 is 0.014 gram per ml. Find the molar concentration of solution. Molar concentration of solution. What is the formula? Concentration is equal to D by molecular weight. But here density means we are going to be finding here, see, here we are taking density is nothing but N by V, right? Sorry, yeah, density is nothing but mass by volume. Volume we are taking here liters or ml? Liters. So we need to convert here density into liters. They given 0.014 gram per 1 ml. 1 ml having 1 ml having 0.014. 1 liter means how many mLs? 1000 ml having how many grams? Then X is equal to 14 grams. So now we can write concentration is equal to density means 14 by molecular weight of N2, 28 means 1 by 2, which is equal to 0.5 molar concentration. Next, types of equilibrium constants. So here a small point, active mass of pure liquids and pure solids is equal to 1. Why we are going to be taking it is 1, 1 means the active mass which is going to be depends on density and molecular weight. So density of pure liquids and pure solids are constants. There is no changes in the density of pure liquids as well as pure solids. So the density is constant. Molecular weight also, liquid and solids also, so constant only. So the active mass of these two are constant. So the liquid, pure liquid and pure solid active mass is nothing but 1. Whenever you are getting an equation, for example, CaCO3 in solid state, which is gives rise to CaO in solid state plus carbon dioxide in gas state. How can you write that equilibrium constant? Product concentration by reactant concentration. But here, what are the products? Calcium oxide in solid state into CO2 in gas state by CaCO3 solid state. So these two values, CaO in solid state which is equal to CaCO3 in solid state which is equal to 1. It is pure solid. It is pure solid. So if you are taking pure solids, the concentration will be equal to 1. Why? Because that active mass is which is going to be depends on density and molecular weight. Both are will be constant. Types of equilibrium. First one is Kc. K is nothing but equilibrium constant. C is nothing but concentration. Kc. First equilibrium type of constant, equilibrium constant concentration, equilibrium constant. Now it is or the active mass is expressed in terms of concentration, then it is going to be derived by equilibrium constant Kc. Active mass which is denoted by concentration or represented by concentration, then we are going to be find out the Kc. It is applicable for aqueous products or reactants and gaseous molecules. It is applicable for aqueous or gases. It is not applicable for solids and liquids. Why? Because if you are taking all reactant or concentrations will be 1. Products concentration is also 1 for liquid and solids. For example, I2 I am taking a solid state plus I minus in aqueous state I am taking, which is going to be I3 minus I am taking here aqueous. So equilibrium concentration Kc is equal to, if they are given values in concentration, we should go with Kc. Kc is equal to I3 minus concentration in aqueous state by I2 solid state concentration into I minus aqueous state. Here I2 is equal to I2 concentration or active mass, which is equal to 1. So what is the Kc here? I3 minus aqueous state by I minus aqueous state. So this is equilibrium constant in terms of concentration. Next equilibrium constant is Kp. P is nothing but pressure. Kp, it is one of the equilibrium constant. P is nothing but partial pressure. Now, why we are showing difference here? P means if the active mass, is expressed in terms of pressure, then the equilibrium constant is shown by Kp. It is applicable for those reactions which are having own at least one gaseous molecule. Why? Because we are discussing about pressure. Pressure will be formed by gases only. There is no pressure for liquid, there is no pressure for solid. Means they have but they won't apply. But gases will be, they will be move. So they are going to be hit to the object, they will be show some pressure. So we can discuss about the reactions at least having one gaseous molecule. It is applicable for at least those reactions having at least one gaseous molecule. Kp, which is equal to, take the reaction, CaCO3 in solid state plus decomposition of CaCO3 in solid state is going to be formed, sir. CaO solid plus CO2 gas. Now Kp is equal to, there is no pressure for this one. We need to give it for only this one. Pressure of CO2. PCO2. So that is the formula of Kp. Equilibrium constant will be same for everyone, but there we are going to be discussing about concentration of reactants and products. Here we are discussing about pressure. For example, take the ammonia reaction. N2 plus 3H2 gives rise to 2 moles of NH3 gas. This one is gaseous state, this one also gaseous state. Then Kp, which is equal to pressure of NH3 square by N2 gas into H2 gas whole cube. So it is equilibrium constant for Kp in terms of pressure. Completed. Third equilibrium constant is Kx. X is nothing but mole fraction. If the active mass is going to be expressed in terms of mole fraction, then your equilibrium constant will be Kx. It is applicable for gaseous reaction. It is applicable for gases. Active mass is expressed in terms of mole fraction. Then the equilibrium constant is Kx. A gaseous reaction gives rise to B in gases. Kx is equal to mole fraction of products by mole fraction of reactants. X of B by X of A. Next, relation between, or take some examples. Write the equilibrium constants Kp, Kc for the following reactions. The first reaction is CH3COOH, aqueous state, which is going to be dissolving water, which is going to be taking liquid state. The product is CH3 C2H5OH, alcohol I am taking in the presence of liquid state. It's going to be forms CH3 COOC2H5 aqueous plus H2O in aqueous state. Write the Kp and Kc both. Second one, NH4HS solid state, which is decomposes into NH3 gases plus H2S gases. Third one is SO2 gaseous state, 2 moles, O2 gaseous state, which is gives rise to 2 moles of SO3 gases. Kc, which is equal to products concentration CH3 COO C2 H5 concentration by C2 H5 OH concentration into CH3 COO H concentration. Kp we cannot express. Why? Because there is no gaseous molecule in that reaction. Then second reaction, Kc is equal to NH3 concentration into H2S concentration by this one is a solid, NH4HS is solid, so we cannot write. If you are writing also, the value is 1, it is Kc. Then Kp is equal to, these two are gases. Gases means pressure of NH3 into pressure of H2S. Next, third one, these also all gaseous molecules. Then Kc is equal to SO3 concentration square by SO2 concentration square into O2's concentration, and Kp, which is equal to SO3 pressure by pressure of SO2 square and pressure of O2. If they expressed in mole fraction, Kx is equal to mole fraction of SO3 by mole fraction of SO3 whole square by mole fraction of SO2 square into mole fraction of O2. Fourth one, H2O in liquid state at equilibrium it is going to be form H2O vapor. Write Kc and Kp. Kc for this reaction. H2O liquid vapor I given. What is the Kc? Vapor is nothing but gas. Then concentration of H2O vapor or gas by H2O in liquid 1. So this is Kc. Then Kp pressure of H2O vapor, that is Kp.